Hey guys, welcome back to my YouTube channel. In this video, I am going to be talking about proof of work. Let's understand what is proof of work. Proof of work is a cryptographic proof in which one entity, we call it the prover, proves to the other entity, the verifier, that a certain amount of computational effort has been expended. The concept was actually invented as a way to deter denial of service attacks and other service abuses such as spam on a network from a malicious service requester. Now, using proof of work, entities can either prove their genuineness or prove that the work they did or changes they made to the system is legitimate. There is a key feature of proof of work, it is their asymmetry. The work or the computation must be moderately hard yet feasible for the prover. On the other hand, the solution must be easy to check for the verifier. Now let's see an example of a proof of work system. Hashcash is a proof-of-work system used to limit email spam and denial-of-service attacks. It has now been extended to be used in Bitcoin and other cryptocurrencies as a part of their mining algorithms. We will see this in the upcoming slides. For email users, a textual encoding of a hashcash stamp is added to the header of an email to prove that the sender has expended a certain amount of computational effort before sending the email. Let's have a look at the hashcash stamp. The hashcash stamp is called as X hashcash and it consists of the following component. The first one is the hashcash format version. The second is the number of bits that should be 0 after hashing. What I mean is that after the SHA-1 hash of this hashcash stamp, the result should have that number of leading 0 bits as provided in this section. This will then be used by the verifier to check if the hash really has that number of leading 0 bits or not. If it doesn't, that means that the email is a spam email and it is not the legitimate one. Now there are other metadata concerned with the email such as date, the email, extension, etc. But the another important metadata is the counter, which is actually the way how the sender tries to manipulate and find out the resulting SHA-1 hash adhering to the number of bits given in the bit section. So the counter will be decided by brute force and base64 encoded and added to the header by the sender in such a way that the 160-bit SHA-1 hash of the header has 20 leading zeros in the case of the example shown. The receiver, however, can at negligible computing cost using the hashcash header and hashing it using SHA-1 can verify that the stamp is valid by checking if it really has 20 leading zeros or not. So in this way, the receiver can identify if the given email was a legitimate email or was it a spam email or not. Now let's understand proof of work in terms of a blockchain, or more specifically in terms of Bitcoin. Since a blockchain is a peer-to-peer decentralized system, the double spending problem has to be avoided. Now the double spending problem is avoided by using a consensus mechanism that helps to validate the transactions in a new block. Proof of work, hence in this case, is used as a consensus mechanism in a blockchain. In this mechanism, the provers are the nodes called miners who solve a cryptographic and computationally heavy mathematical problem. Let's have a look at the block. So this is a typical Bitcoin block. The block consists of metadata such as version info, previous block hash, Merkle root, which is the Merkle transaction hash tree, and the Merkle root is the root transaction hash, and the block timestamp, the difficulty bits which set the difficulty of the cryptographic problem, and the nonce variable. The nonce variable is important in this case because miners try to find a nonce. After completing the SHA-256 hash of the block with the assumed nonce, the block hash should solve the difficulty bits as required. For example, the resulting block hash should have 4 leading zeros. So in this case, the miners will try and manipulate the nonce value in such a way that the resulting block hash should have number of leading zeros as specified in the difficulty bits. Now, once a block is mined, it is broadcasted to the network and other miners verify the block hash with respect to the difficulty bits. In this way, the miners are also the verifying entities in context of proof of work. So in a blockchain, the miners can be both the provers as well as the verifiers. Now let's have a look at pros of proof of work in terms of blockchain. Proof of work is a tried and tested consensus mechanism that has kept Bitcoin and Ethereum networks secure and decentralized for many years till now. Compared to other potential consensus mechanisms like proof of stake, it's relatively easy to implement. Now let's have a look at the cons of proof of work. Proof of work, since it needs a computational effort to be expended, it uses so much energy that it's bad for the environment. Now, if you want to start mining, you would need such specialized computing infrastructure that it's just a big investment to start. And as the number of transactions start growing, as the number of blocks to be added starts growing, the number of computational efforts will also grow directly. So due to increasing competition needed, mining pools could potentially dominate the mining game, leading to centralization and security risks. What this means that as the competition required will start growing, individual nodes would be not able to cater with the computational needs. So they will start forming groups with other miners, and this would lead to a formation of a pool called mining pool. So in blockchain, we are talking about decentralization, but as a result, to cater the growing computational needs, it will eventually lead to the formation of certain groups, which will again have the format of centralized authorities. So this will not only lead to centralization, but also can pave a way for security risk. If consider, for example, these groups itself have the motto of malicious intent, they can lead to attacks such as the 51% attack. So that was it for this video, guys. This was a quick overview of what is proof of work and how the concept evolved and how it was applied to a blockchain ecosystem. So if you liked this video, please hit the subscribe button and stay tuned for more such upcoming videos. Bye.